to this computer. All right, good to go on that. Just admit. All right, how's everybody doing this morning? Little humid out in the classroom location at least. Um, oops. All right, we've got we'll say 3 more lectures, including this one. So let's see if we can set our bases here. So started. Good morning. Just trying to make sure everyone is added as properly.
Hi, good morning.
Good morning. Good morning. Okay, let's see. So we have today, let me pull up the syllabus so I can have a reference point here. All right, so this is week 6. And as advertised here, we're going to talk a little bit about game theory. A little bit about advertising in the game theory. We might get into that a little more next week as well. Just up to today's lecture, we're going to be, I've covered the highlights. We're going to cover the highlights of chapters 1 through 15. So today's material, if we get through it all, is going to go through the main points, and I believe chapters 11 to 15. So put a note of that in the PowerPoint, but just making sure everybody's added. Okay. Okay. I think we'll get through everything today, but if not, we can always pick up the leftovers next time. We do have 2 more meetings, but just note that the homework from homework number 2 is due today. I have received a number of them. Apologies for not saying like giving you a receipt email, but I'll do that later today. So if you've sent it, I know I've received like 5 or so of them. So I've probably received it. Just I'll confirm later. But that homework is due tonight at midnight. So feel free to post or email it to me if you're done, or you have up until the end of the day if you need it. I know you got this class and your other class, but you know, up to you when you want to submit that sometime today. And then we are ramping up a bit because we have only a few weeks left. So I have another homework that's going to be due next week, October 4th. And then assuming everything goes on schedule, I'll have a take-home final ready for you next week. And then that will be due week 8. And we still will have a class.
Chat. Mm.
Oh, is there a question?
Oh, no, sorry.
Okay, all good, all good. Okay, and we will have a class on week 8 as well, but that's the schedule. And again, the only thing that I haven't updated on here is the readings. So up to week 6, which is today, we'll have covered the main items in chapters 1 through 15. All right. And the plan will still be to cover up to chapters 20 in your textbook. And I think that'll be a good amount of material. That's a lot of chapters. So again, up to 15 today. And as always, if I don't hit on a particular item that you would like to discuss in one of the chapters, let me know, and I'm happy to divert to a new topic. Okay. Everyone good on the logistics timeline? Okay. All right. Okay.
I have a question, Professor.
Yeah, please.
For next week's homework, do you have an idea of how many problems we're having?
The one that's due next week?
Yes.
I do. I just posted it this morning.
Okay.
We'll get to that. I think, well, there's like 3 sections with multiple parts. So a similar link to the previous 2, I think. Maybe a little shorter, but yeah, it's right here, homework number 3. We'll get to that later today, but well, I'll just give you a preview. As was asked, get this little top bar to get out of my way from Zoom. There we go. There it goes. Okay, so this one will be due next week. We haven't got to all these items yet. Most, if not all of the homework for this homework is from the chapter 15 game theory section. So we have to get to that first, but there's, there's a part 1 with some textbook questions. There's a part 2 with and a part 3 with some questions I had previously prepared that I like to test the game theory knowledge. So I don't know how to answer the question, like how many questions, but 3 main sections with multiple parts. Okay, and I did post last week's recording on the playlist. I think I did it like right after class, so you should have access to that. In case you missed anything from last week's lecture, I'm recording this one. Assuming everything goes well with the recording, it has been lately. I will post this one as well to the playlist. And I think that's all of the catching up logistics. So last week's lecture is posted. Instructional solutions has been updated because there's only one assignment due yet. Homework 3's being sent out today or posted today. Homework 2 is due today. And then we got a bunch of new content today, but just wanted to get the level set before we jump into new material. Okay. Okay. We're good to get started. Let's go to lecture slides. Okay. So the new stuff I've posted today is there's a 4 market model summary, which maybe we'll get to right before game theory, chapter 10. And then there's a lecture slides week 6, which covers, again, the highlights from chapters 11 to 15. All right, so let's open up lecture slides. Actually, it's usually best if I just download this. I'm going to go into PowerPoint mode. So let me know if if you see anyone in the waiting room or if there's any comments, because I'm just in presentation mode now. Okay, so this is the main content I thought was good to talk about for chapters 11 to 15. A good portion of today's content and homework assignment will be from chapter 15 because that's the game theory one that I wanted to spend some time on. We will get through some of the other things, but that'll be we're building up to chapter 15 today because that's the bulk of the homework. There. All right, so and I will say that where I start. So chapter 11 is on like bubbles and exchange rates, and then chapters 12, 13, and 14 are on like pricing and price discrimination, and chapter 15 is on game theory. So there's a lot going on in these chapters, and what I'll preface is that like chapter 11, the bubbles and exchange rates, which we'll spend a little bit of time on, and also chapter 15, which is game theory. Both of those could be a whole separate class. So I have it it's hard to cover everything that I want to cover for those two because that's you could have a class on exchange rates and bubbles. You could also have a class on game theory. So just know that if you want to deep dive into either of those topics, I could look into some, supplementary readings, or I'm sure you can even find textbooks or classes if you're interested on those whole topics. But there's a lot more that goes into some of these chapters that are not highlighted in the textbook. So just note that if you're interested in exchange rates or bubbles, or B, game theory, you can go much deeper into it if you're interested. And in fact, I've taken whole multiple courses on both those topics. So, all right. So just some of the highlights from the bubbles exchange rate chapter. So we'll look at the next slide here for a quick example on U.S. home ownership rates for about a 30-year period. So if we look at the housing market, we'll see that in 1993, the government, put through some policies that encouraged low-income homeowners to buy houses, which was pretty effective, before the bubble crash. And then the government reduced qualifications from borrowing from government-sponsored lenders like Fannie Mae. We know a lot of that's led up to in 2008, 2009. And that led to an increase in the supply of credit that would-be homeowners, and an increase in the demand for housing, which led to an increase in the rate of ownership. So when you look at the next slide, you'll see that both before the slight bubble increases or homeownership rates, there was some encouragement from the government, and then some other players to try to get more people to able to buy homes. And in that aspect, at least in the initial part, it was successful. But a lot of times these policies have trickle down effects or unforeseen consequences that you want to get more people buying houses, but you don't want to get people buying like 2, 3, 4 houses, which happened a bit during the 2008, 2009 period. So what I want you to look at here is this is from the textbook. So we can look at, my guess is this is increased again, but this is the U.S. home ownership rate from 1990 to 2021. And what you see is in the early 90s, there was some clear government policies that encouraged like lower lending or lower interest rates, or just a lot of policies that encourage home buying. And you can see how successful that was in terms of that policy aspect, was to get the home ownership rate from 64% to about 69%, which doesn't maybe seem like a huge jump, but it is. That's millions of homes. And then what you also see is that the home ownership rate went down a bit because those policies, escalated into situations where there was some lending from bad credit investors. There's especially in like 2008, 2009. Everyone knows the story, but the mortgage-backed securities situation where lots of outside players and even like international players were investing in home ownership because it was such a hot topic. And home ownership kept going up and up and up. But the problem was eventually those interest rates that were flexible or adjustable, adjusted to higher rates. Lots of homeowners took on multiple houses or houses they couldn't afford except on paper. And eventually that led to a situation where lots of people left the market. But the point of this is we're trying to illustrate or identify bubbles. And it's very difficult because, if you're in this point, even if you think there's a bubble, why do you have an incentive to get out of it? Because if it's almost like you don't really need to divert until it really hits the downturn. And then once it starts hitting the downturn, you're like, okay, now I need to. But if everyone thinks like that, it really doesn't matter if you see a bubble or not, because everyone wants to ride the bubble to the last bubble pop, I guess, and then it pops anyways. So I think it's clear that a lot of people recognize that this was an inflating bubble situation, but still wanted to reap the benefits. And so even if you can recognize a bubble in this sense, it's difficult to number one, like be sure when it's going to end, and number two, get people to act differently, and then number three, like change your behavior if everyone else is doing the opposite. So that's the lesson with this, and
Isn't that moral hazard?
that's moral hazard. Well, moral hazard is being more compensated, like moral hazard is the situation where like for all the gains in the housing market, all the investors got 100% of the profits. But if everything went under, they were only responsible for something like 50%. So the expected gain was much more than the expected loss, because
Okay.
the expected loss was only half of what they would have to pay. It's like moral hazard is like going to like a blackjack table, and if you win, you get to keep 100%, but if you lose, you only lose 50%.
Wow.
So if that was the situation, everybody would keep playing because, right, it's you're not fully responsible for your losses because of the effects on the economy, but you are fully, responsible for your gains. So it's a bit of a tricky situation. And then the follow-up slide here is leading into the bubble collapse, if you will, in 2008, 2009. Especially in areas where the supply was limited by strict zoning laws, such as California and Florida, which means that it was, these policies had less of an effect or less of a negative effect in rural areas where you could keep expanding. But as you probably know, in California, I don't know so much about Florida, but let's just group them together. But it makes sense because it's on a giant peninsula, and you can't really keep expanding unless you keep jumping to different keys or whatever or whatnot. But there isn't a lot of ways to go in Florida. Like three of the directions are water, so that's a limiting constraint. In California, Southern California, we got the mountains, and you're probably aware that it's really difficult or more difficult to expand in California because of all the zoning laws, all of the pushback against it. There's always like if my house is worth $1 million and you put a bunch of houses near it, there goes my home value. So when you get a really high value of houses, the homeowners don't want more houses because it would push their home value down and stuff like that. So it was more difficult to expand in California. As I mentioned before, many of the participants, it worked in buying a new house, but they bought a second house or even a third house. Bankers thought the money was safe, or I don't know if that's the right way to say it, because I think a lot of the bankers knew it was risky, but still wanted to ride it out until it collapsed, kind of thing. And then, as a consequence, banks were willing to lend to very unfavorable terms, like having no credit or adjustable mortgages that basically you could get into a home with nothing down at like 1%, and then a few years later they're like, oh, your rate's adjusted to 20%. So just these tricky terms got more homeowners into the market, often multiple houses. And as the textbook and everyone has pointed out at this point, if you've read any research or watched The Big Short or anything like that, you know what happened. But the point is that even if you see this bubble happening, how do you know the bubble is gonna pop? And even if you do, what's everyone gonna do about it? So that's the whole lesson, is identifying the bubble is only one thing, as I'm sure there were like researchers and economists who probably saw some of this coming, but it doesn't mean anyone's gonna listen to it, right? So I don't think we thought the extent of this would result after 2008, 2009. But yeah, so right. Okay. All right. So then there's a theory in your textbook that proposes how you might be able to identify bubbles. And essentially the theory is, this is the stock price earnings ratio, right? So this is like the average, if this is like the New York Stock Exchange or the NASDAQ, this is the average rate of return. And what you see is over time, the stock market is expected to give a rate of return because I mean, you're investing in companies, and on average, those stock prices or those dividends pay off. But you see here that so if let's see, the stock price earnings ratio is the mean is like 17. And you see certain situations where it goes up to like 30 or even north of 40 here. And I have to look at what it is in 2020, but the claim or the theory is that stock market or other bubbles revert back to their long run average value. And so if you look at 2003 and 2007, there were these two episodes where stock prices went super high in terms of the stock price earnings ratio, like right here. And I don't know if you can see my mouse, but in the stock market crash of like around 1929, and then in 2000, which was that dot-com bubble burst situation. So if you recognize, or the theory is if you recognize that the return on the stocks or the return on whatever bubble is much more different than what you're expected to see in the historic average, then you might be in a bubble. And then, in both cases, prices crashed after reaching their heights in 1929 and also 2000-ish. So put a question mark to myself. Has this happened since 2020? I was going to look at the stock price earnings. We can do that in a second. And then, do we agree with this theory? So it's a good theory. The problem is, what if this long run mean adjusts? So like this long run mean looks pretty looks like a pretty good theory till about 1990. Now, since then, I don't think that mean is reflective of what's occurred in the stock market. There's been a few dips, but for the most part, there's the 2000 dip, and there was another dip in 2008, 2009, 2010, which we can look at. But if you recognize this is your theory, and you say, okay, eventually it's going to go back to the mean, and then in 25 years it doesn't go back to it, you might want to adjust your mean, right? So this theory is only as good as until you've realized that, wait a minute, this variable or this bubble, or this isn't a bubble anymore until it hits 50 or something. So let me see if I can find so stock price range. I don't know what it is. How about that? Yeah, okay. So here we go. So this is the if you can see that, I'm trying to see if I can make it bigger, but it doesn't seem like that's the situation. So hopefully we can see that okay. So in the previous graph, we were somewhere around 2020, right? And what was the identified mean was 17.36, right? And if this is the same, it looks like the same graph. So 17.36 is, I don't know, it's below 20. But the point is, like, since this point, um, it doesn't seem like that theory, maybe that theory holds, but we're gonna need to adjust the mean because since this point when the stock market dipped after the, homeownership crisis, whatever you call it, the great reset or the financial crisis, sorry. It seems like we're at 18 and north of, there was that a couple of dips in January, but if you think the stock market, this ratio is coming back down to 17, that's possible. But I would bet more so that we have to adjust the average to something like in the 20s, because it doesn't seem like that ratio, at least there's no evidence that it's going to come back down to 17, right? So right here, when you saw it went to 37 or 36, probably a good chance it's coming back down. But I wouldn't bet on this coming back to an average of 17, right? So that's the point I'm trying to illustrate is that, yeah, it's good to recognize that these jumps probably are coming back down, but it seems like we're in this plus 20 range from here on out until someone tells us otherwise, right? Okay. So just try to go through bubbles really quickly with a couple examples. Any questions on that or any contradiction to the theory in addition to that one?
So I had a question.
Yeah, please.
So on individual stocks, is it possible? I know it's possible, but I wanted to see if you want to do a real time stock price to earnings ratio on a stock.
Sure, I can do that. I mean, I'll just look at, yeah, that's a good point. So,
So the stock I wanted to see is Palantir.
which one?
Palantir, the ticker is PLTR.
I want to say this one right here, right? Yeah. So, yeah, you're looking at quite above the average, yeah.
Oh yeah, so they're speculating that it's a bubble now, but it still has growth.
Yeah, let's see, this is a good example because you're right. You might have or I don't know if you did, but this might have been recognized as a bubble. We might all agree it's a bubble, but even so, like, are you sure that it's not going to keep going up? I guess I wouldn't, based on what's happened here, since what day was this? 2023. It seems like this has had it's gone up and down a bit, but it it might be a bubble. But I don't think you'll get a lot of investors that are deterred, right? Unless you see this thing dip down pretty good.
I agree.
Yeah. So I don't want to tell you to buy the stock, but I bet a lot of people will until something happens, or yeah, it might continue to grow and then level out at some point. But yeah, good question and good example because right, that might be how you look at a bubble. Just well, that could be a bubble. But you know, do I want to short that? Probably not. I don't know. Yeah.
So what's
I probably wouldn't.
what's the guidance on? I mean, if we're talking about bubbles, I mean, if we look at these trends, you're still taking a leap saying it's a bubble, right? Because
Yeah.
you don't know if it is indeed the top of it or what. So
That's the takeaway. There is no,
okay, that makes sense.
if there was, everybody, I mean, the takeaway is like, it's hard to recognize bubbles. And even if you do, does it make sense to assume that the bubble's gonna pop today?
Yeah.
Or should you just wait till, everyone? I mean, if you were sure that it was gonna go down to as the average, which is, what did we say? The average was like 20, and this is like, this is tenfold on
Yeah.
that, so. Yeah, probably is a bubble. I don't think it's gonna keep going up like this forever. But maybe it does for the month or year, or I don't know. Not sure, but definitely definitely a good example. There. All right. Okay, so just get on here. All right, so in the rest of this chapter had some a little bit on currency appreciation and exchange rates. I put some supplemental links because I wasn't the way that the currency appreciation exchange rate discussion went wasn't super easy for me to I guess follow and communicate to the class. So I'm not going to test you on this, but there's a couple links here. This one I really like from Investopedia, which is pretty good on these financial topics. And usually they have an article that's like really recent. I mean, back to this one is 2024 is one of their older ones. Probably someone's going to rewrite this soon, but they do a pretty good job of, they'll give you a little example, and they'll define the variable and show it in practice, and then show like, additional topics that you might be interested in. So there's, to show you where else. Where's the discussion on? Let's see. Right here. Okay, so in simple terms, currency appreciation or depreciation is an increase in the value of one currency to another. And so normally, you're often comparing it to the dollar because you're looking at the dollar's exchange rate. And so it can happen for a number of reasons, but essentially like if and I had this other link to show you what we could look at in real or so this is I think a pretty current exchange rates website. So what you can see is all the ads. I think I can't. Sometimes I can't even like use the website. But it does have like the rates to. It's like like I don't know how they figured this out. It's just like the ads come in like different ways. It like pops up or it like comes from the side. It's like, so here we go. So this is, as of now, the top 10 US dollar exchange rates. So one US dollar would get you 0.85 euros, 0.74 pounds, about 89 rupees, and so on. And then it's the ones that are like, like the rupees or the yen or like where's the Mexican pesos? Yeah, 18. So I find it much more difficult to think about it or like do this transition in my head, especially when you're on vacation or like it's not too bad if it's like 0.85 because it's almost the same. Not almost the same, but when you try to convert or do like if you go to Japan and the exchange rate's 145 149 to 1, or if you go to Mexico and the exchange rate is like it was 18, it's more difficult to figure out what you're doing because it's just harder when it's not a closer to a 1-for-1 situation. But the point is like, so if the dollar gives you more, so if here's the US dollar to euro exchange rate. So it's right now 1 to 0.85. So if the exchange rate goes to 0.9 instead of 0.85, is that an appreciation or a depreciation? Are you getting more or less? So right now, if you give them if you go to the currency exchange in Europe, like at the airport, you give them $1, you get 85 cents. If now tomorrow you give them $1, they give you 90 cents, is that better or worse?
Better.
It's better, right? So the currency appreciated. It's I know it's trickier than you think about, especially when it gets to like these ones. But and then if the dollar is worth less, let's say it goes to like 0.75, just think about it like if you're exchanging your dollar, you're only getting 75 cents now, and now it's depreciated. So I wish I had more knowledge on why these things fluctuate so much, or maybe they don't anymore, but it seems like I don't travel that often anymore, but anytime I go to somewhere, like the exchange rate is way different than it was before. So the most recent place I've gone to use different currency is Mexico. And even with the like 18 to 1, it's still quite a bit different because you're almost like you buy a coffee and you give them like 100 pesos and you're like, wait a minute, that's nothing. It's only like a few, but it's important. And then some of these that are like much different, like the real, good luck trying to figure out that out when you're doing the exchange rate. But if you look on here, and some people might be interested, I've heard people say like, oh, I'm going to place blank because the dollar, that you can get a good deal on the currency, like the exchange rate appreciated, but it I think that's a difficult practice. Like, I don't know if there are a lot of people that are, if the Japanese yen goes to like 200, or a lot of people are going to go to Japan to get that exchange rate appreciation. But that's the idea is that when these things go up or down, if you're getting more for your dollar, the dollar is appreciated. But if you're getting less, it's depreciated. And all these other countries are probably doing the same, is the idea. So again, this could also be a whole separate topic. We're not going to deep dive into it too much unless you all want to explore additional topics. But any questions or feedback on exchange rates, what they are, what the purpose is. Appreciation, depreciation is the main thing, but if you look at this table, it's good to have a reference point because you can see like, okay, like if the pound goes, the exchange rate goes to 0.8, I'm getting more for my dollar, or vice versa. So that's what appreciation, depreciation tells you, and it can change, and the dollar can appreciate or depreciate compared to these other currencies for a whole number of factors like tariffs, demand for a certain good, stuff like that. Okay, so those two links, currency appreciation and exchange rates, are here in the PowerPoint. You can take a look at that Investopedia article if you will. It's pretty good. And then if you want to track the exchange rates and be like, oh no, I can get more for my money here, you can do that too. All right. Any questions on that? Was chapter 11. So mostly on bubbles and currency appreciation and exchange rates. So we covered that. We covered the highlights pretty quickly, but I think we got some main examples and some good definitions. But let me know if you want to explore anything else. You can always add more topics on the last class. But yeah. All right, so if there's no other questions on those topics, we'll move on to chapter, I think, 12. Okay, so chapter 12, 13, 14 are in essence about price discrimination and different pricing strategies. So I didn't put a whole lot in from chapter 12. It's mostly just like talking about your business pricing needs or strategies change if you have multiple products, which makes sense. And so a lot of the stuff we learned, like price where marginal revenue equals marginal cost, or look at your competitors, is different if you have multiple products, which most firms do. Amazon has millions of products, and Target and stuff like that. So this is a good little summary, except the second bullet point I put a question mark because when I put it from the summary, I wasn't sure if that was 100% true, but let's look at these. So if you are a business and you have a substitute product, like you own like Coca-Cola, and you also own like another less expensive soda. So you have substitute products, you have Coke and you have store brand Coke. The rule of thumb, at least from the chapter, is to increase revenue. Raise the price on both products to reduce price competition between them. So essentially, if you own, we learned before that like if you price your substitute higher, then the consumers would buy the substitute, which is cheaper. But if you have them both, or more than both, then you can have a little more power. And like, all right, if I'm a grocery store and I'm selling Pepsi, Coke, Sprite, if I'm Coke individually, I don't want to price my good too much higher than the other substitutes. But if you increase the price of all of them, what's the consumer going to do? Like they have to buy one of them or not. The second point, which I put a question mark because I wasn't sure that was 100% correct, is raise the price more on a low margin, more price elastic product. So what that would mean is if you have two goods and one is more price elastic. So maybe if we can think of a store that's selling what's something that's like price elastic is most like, let's say cereal is the more low margin, more price elastic. So let's say cereal is the more price elastic, right? Lower margin. And let's say the more inelastic or higher margin is like barbecue, maybe. I'm trying to think of some examples. So would it make more sense for the grocery store or Target or whatever it is to raise the price more on the cereal than the barbecue? Maybe. I'm not sure if that's a hard rule or it's just easier to do that for the low margin good. And I took this out of the summary in the last part of the textbook, and I didn't think about it more, because we know from before that if something is more price elastic, you want to lower the price, right, to get an edge on your competitors. And if it's more inelastic, you could increase the price because the consumers you lose would not offset the additional gain. So I think that would be a case by case scenario. Bullet point 2, but would have to do. I guess the point is like your strategies change a lot when you're looking at multiple products. So it might be just maybe, well, I guess the one thing I would say is like on average, you're probably getting more people to buy cereal than barbecues. So if you sell one barbecue a week and you sell 1,000 boxes of cereal, then maybe just increasing the price of cereal a bit would increase your revenue. But maybe you sell 2 barbecues. I don't know. And then last point is reposition the product so there's less substitutability between them. And that would mean essentially you're trying to not have two products where the consumer buys one and then just, if you have, let's, for example, if you have two types of cereal, this is like Trader Joe's, and cereal substitutes. If you sell more of one, you're probably gonna sell less of the other, right? So if they're substitute goods, what you could do is maybe make one of them like a breakfast bar or like oatmeal or some kind of something that's a little bit different, because I think the point of that last bullet point is if you sell two similar products, consumers are going to buy one of them, and if they buy one of them, they're not going to buy the other. The last bullet point here is if you have complementary products, the rule of thumb was to reduce price on both to increase demand for the products, and this is like the obvious, or one of the textbook discussion examples is like iPhones and the like apps that go with it, right? And so if you can reduce the price of both the iPhone and the complementary apps in comparison to like the Pixel or something like that, then that might give you some more consumers, because you wouldn't really want to reduce the price of just, or increase the price of one, because that would, as a bundle, negatively affect the consumers. So these are all just discussion points, but the point is, like, if you have multiple products and there's substitutes and they're complements, there's quite a bit of strategic thinking going on in what you do to your products, in addition to just the one good scenario. Okay. I have, oh yeah, I had a couple examples. So these are from chapter. Did we just do chapter 12 or 13? I can't remember. I think this might have been my only slide from chapter 12, which was on pricing of multiple goods. And then this is chapter 13. Next one. Okay. Any questions on this slide or anything else from if you read chapter 12? I didn't cover it, there wasn't a whole lot to discuss, except if you have multiple products, things change. Like, and it depends, but that's, yeah. So if we jump to this slide, I think I just jumped to chapter 13, but this is also a extension of chapter 12, which is on pricing and price discrimination. So these are examples. When the Macintosh computer was introduced in 1982, Apple made it difficult for third-party software developers to develop software for the platform. I think that's similar now, because I think a lot of the software that runs on Mac is much different than runs on Windows. So the like computer or the desktop laptop strategy was make all their software and products like in-house and not make it compatible with others. And then the second bullet point is, in contrast, Apple makes it relatively easy for third-party developers to make apps that run on the iPhone. So compare and contrast these two strategies. I guess I kind of did already, but the point is that the first one, there's two completely different strategies from Apple here. Is one, make things impossible for competitors or complementary products to run on your software or your computers that aren't made by Apple. And number two, make it so anyone can make an app so they can, sell their product on the iPhone. So I'm not sure which one is the better option, but you can see the extremes of what the same company did for two separate markets.
I think the latter is the better move. I mean, you can see that with Microsoft too. 2014, and then their current CEO starts taking Microsoft software out of silos, right? If you want to run Microsoft products, you got to use Microsoft, hardware now. I mean, there's sort of, I mean, you can run Microsoft products in their fierce competitors' cloud environments.
Yeah,
And they kind of play nice with each other. I think that the latter is probably the better way to go.
that's probably, yeah, I can see that. I mean, it's a little, I mean, Microsoft has the most of the market in that, like with most computers run Windows and Microsoft Office. So they've already they've somehow combined them, I guess.
Mhm.
So they make it so like it, any business or I haven't worked for a lot of companies or um firms or even universities that make that the default computer is an Apple or a Mac because they're a little more expensive.
Yes.
So when you make it so essentially the default option is Windows, you're not saying that you can't run other software on it, but most of the or a lot of the software runs Windows and Word and Excel. So, but they also make them compatible with other things, right? So it's a bit of a different strategy, but yeah, I think maybe the answer is see what you can do with both of them. Okay, and then another question, just a thought exercise is concert prices have increased coincidentally with illegal downloading of music off the internet. Why? So pretty self-explanatory, but why is that the case? Yeah, so essentially what this, and this is similar to the Spotify era, but a little bit different, but when we had um Napster, I don't know if any of you were part of the Napster era or even like the I can't remember what the additional ones were called, like
LimeWire.
LimeWire, and there's like a DC situation. But once music became MP3 digital, consumers didn't want to pay full price because they could share it, and it became this big, sharing of music market. At the same time, the artists probably, a lot of artists at the time were like completely against uh, digital music and music sharing, even Spotify for a long time. I think like some of the examples I can think of are like Metallica and even like the big ones off the top of my head are like Metallica, the Beatles, Dr. Dre, even like I think Garth Brooks is still even like not on Spotify. So I don't know why. But what they realized is like, well, this is a changing market, and the way to make money, if it isn't with record sales, could be to have more concerts, live music. And what happened is this the number of shows or live musics or even festivals or whatever you call it, like has increased exponentially since like 2000. So it's no coincidence that there became an expanded market for live music in comparisons to like Coachella, because if music was essentially free or $20 a month, or you're only making money if you have a hit that get millions of downloads and plays, then the other way to make money was to make the market for live music, because you can't share that, right? It's you have a ticket, you go, nobody can listen to it unless they pay for the ticket. All right, article. Now, next topic. Time we have here. We're good. We're doing well on time. Okay. I thought we might have a little crunch for time today, but we've already covered chapters 11, 12, and 13, I think. But chapter 15 is going to be the big one. Okay, so I think this is chapter 14, price discrimination, or it's possible that I think they blended. Oh, I know what happened. Okay. So this was chapter 13.
So there's direct price discrimination.
Yeah, there's-
13, indirect 14.
All the chapters like blended together for me because um, the way I thought of it, to go back to the original, was chapter 11 was quite a bit different because it was exchange rates and bubbles. Then chapter 10 was game theory, which was also quite a bit different. And the other ones all blended into me for pricing strategies. So I'm kind of giving you 12, 13, 14 as a bundle because there's similar topics. Yeah. Okay. So price discrimination. The definition is charging different prices to different buyers or groups of buyers based on differences in demand. So the idea is if you can segment the market and understand that there's different demands for different groups, then you can charge the higher price to the more inelastic group and the lower price to the more elastic group. All right, so there's hundreds of examples of this. Movie theaters charging lower prices to students and individuals over like 65. The same thing with like ski resorts. You get a lower price if you're young or you're over a certain age. And you also see like student prices versus business prices. So the example from your textbook was that Target apparently has a strategy that because the segmentation of the market is different, they've determined or estimated, I don't know if this is the case anymore, but that in-store prices or the consumers in store are a little more inelastic, and the consumers online, because they can compare it to anything quickly with like a split screen, or are not so much or more elastic. So apparently what they've done is, or did historically, is charge a bit higher prices for in-store versus online. Now, I'm not sure if that's just assuming that, consumers are different. I mean, it also could be that the cost to put in the store is a little bit more because you got to pay for the labor, you got to pay the rent. So maybe that's not a great one-for-one interpretation, but it seemed like they had to change their strategy of we'll charge more in store, but if you show us a price online, we'll match it. So there's become this like, back and forth of and there's a big Best Buy example where they've succeeded because they're willing to match prices that someone shows them on Amazon or something other. But you got to be careful as an organization, and if you're going to charge quite a different price for online versus in store, eventually someone's going to figure it out and either not buy it or ask you to match it or go somewhere else. But the point is that was an example of price discrimination from Target, is to assume that in-store consumers would spend a little bit more. It wouldn't be as price sensitive versus online, because if you see a price online, you can just flip to a different website and maybe compare it. The other bullet point here, tourists or natives, was, I think, I can't remember the specific example, but it might have been like, let me remember the country they referenced in the textbook.
No, I hadn't read it yet. This is chapter 13.
13 or 14. Let me just.
Chapter 14 talks about how bad the traffic is in Southern California. We're not wrong about that.
Oh yeah, the express lanes example that we're about to get to. Okay, so. Chapter. Yeah,
We're talking about Canada and Mexico for, pharmaceutical drug.
no, I don't, it doesn't even matter what or it doesn't really add to my example, but I think it's on. I think it's on the previous one. I had express lanes. Oh, here we go. Thailand. There we go. So the point is, and I couldn't remember what the country of reference was, but in Thailand, and this is explained in chapter 13. So the tourist native example for Thailand is that the tourist industry has recognized that tourists will spend more for goods and services than natives, and due to the income disparities. So what they'll do, or what they do, I'm not sure if they still do, is for like parks or attractions, they'll have a price for natives, which is much lower, and they'll put the price like in the native language. And then they'll put the price in US dollars for the tourists. And the price for tourists will be like 10 times that of the natives. And unless you can speak the native language, like in Indonesia, you wouldn't know that they were charging a lower price versus higher price. But they've broken down, like, they know that the current citizens aren't going to pay the price that tourists pay. So they give them a lower price. And for tourists, they charge a lot more because they'll pay it. And the example that I wanted to like spin off of this was my like wife listened to a podcast about Bad Bunny, who apparently so number one, I the takeaway was that he's the only artist who has become so big with not doing any songs in English. And number two, he's a native of Puerto Rico. And so what he did recently was, which is actually pretty cool, is for the locals in Puerto Rico, because of the same situation, they don't have the income qualifications that tourists normally do. What he did was had a free concert for everyone in Puerto Rico to attend, and then like the next day had a concert for open for sale to tourists. And you can probably guess that the money he made from the tourist concert was pretty big, and it overcome it covered the free concert. So that's like an extreme example of like natives go free, I'll charge a massive price for tourists. Uh, and then people were like, oh, you did that, I want to go spend all this money on a concert. But anyway, it's a pretty good or pretty good, and it's possible that that strategy and that promotion led to higher prices for the pay per concert. So Bad Bunny was doing like this price discrimination, also like pro bono thing that might have even contributed to more higher ticket prices. So good for him.
Airlines do that, right?
Yeah, is that I have
Oh, okay.
that's coming next. So I want to say this is the next chapter, but this might be 14. I think 13 is price discrimination, and 14 is indirect price discrimination. All right. Okay, so a few more. Okay. Okay, so I believe this is chapter 14, which is indirect price discrimination, which is essentially like not announcing your strategy. Like, so all these different examples here, there's a different price, but it's not like it's not the same as just Target charging different prices for different customers. So express lanes, this is price discrimination because you're charging different prices to, I think the example was the Orange County Express Lane. I can't remember which one it is, but there's a lot of traffic in Orange County, near the 91 or 57 or whatever it is. And you can either sit in traffic, or there's consumers who would be willing to pay a little bit more to go into an express lane. And so what the city planners or whoever, I'm not sure if the express lane is like a private company or more of a public good, but whoever owns the express lane is charging a different price to consumers who are willing to pay a little bit more, or in some cases quite a bit more, to go faster, not sit in full traffic and pay $5, $7, $10 to go in the express lane. So this market has identified consumers who aren't willing to pay for express lanes and consumers who are willing to pay. And by doing that, they separated the market by just saying, like, if you want to go in this lane, you have to pay for it. If you don't, then you don't have to pay for it. And then airline travel is we were just talking about. This is probably the most, one of the wider examples of price discrimination is because airline prices change all the time. So they, if you plan ahead, they're a little bit cheaper. If you wait to the last minute, they get more expensive. If you want to sit in first class, it's more expensive. If you want to check in your bags. So the price of airline travel, and I think sometimes they don't even know what to charge, but all the airlines try to estimate what someone would pay to give them the timeline and how near it is to the flight taking off. So it goes from like relatively cheap to super expensive, and then what happens if it's like the flight leaves today and it's only at like 50% capacity? Then they have to lower the prices again, and then it seems like a very difficult business to be in because it's hard to know. You can guess like during holidays there's more traffic or there's more airline traffic, but when you try to price low, then increase prices until it gets close and then hope that it sells out, and if it doesn't, you have to lower prices again. It's a tough game of price discrimination, essentially. Software pricing, I just put this one in here because a good example was like the student versus business versions of like Microsoft Office or any kind of software. Like you might, I don't know if you have any like statistical packages, but if you're doing like Stata or R or Python, there's often like a student version, which is much cheaper and has a little bit less features. And then a more expensive version, which businesses will pay for because it has all the features. The same, I think they still have like a student version of Microsoft Office, right?
I think so.
Yeah, I think you probably already have it, but that should be complimentary through Laverne. I think they have a subscription, so.
Yeah, it's right in, it's the online version of it
Okay,
through the university's
yeah,
website.
nice. So there you go. And then if you were a business, you might pay for the full version, which has other things like Microsoft Teams, and there's some other options there. Last bullet points with the printers is just to identify a couple price discrimination strategies. So what one of the printing companies did or has done, and probably others, HP, is to try to keep consumers on with HP ink. So a lot of times you can go on Amazon and you can either buy, so you have a printer, it's HP. You can buy the HP ink, or you can buy like the cheaper ink, which is from like, expressink.com that sells on Amazon. But what they've done here is to just have like a subscription or program where like if your printer is getting low, they can run the analysis and just send you it automatically. So if you sign up for that, they've ensured that you'll keep getting these HB brand inks or toners, whatever it is. And then as an alternate strategy, this is like the old Microsoft. Some printers will make it so you can only use their brand cartridges. So if you buy an Epson printer and it only takes Epson cartridges, then you're stuck buying Epson until you get a new printer. And I think it's explained and probably pretty clear that the printing company or the printing market, uh, how do they make most of their money? They don't make it from selling the printer. Normally the printer is pretty cheap and sometimes like nothing. But over time, you're like, wait a minute, I just bought $100 printer, but the ink is 80. So
Oh, yeah.
yeah. So most of these printing companies have imposed a strategy where the printer itself is very cheap, but over time you keep buying these expensive cartridges, and if you don't buy the cartridge, you can't do the printer. So it's another level of price discrimination. One of the final examples in chapter 14 is bundling pricing. So this is what I think the main example was like the streaming bundles. So I know that it's hard to keep track these days, but I know like the Disney, I think there's like a Disney Hulu HBO bundle now. And that would be cheaper than buying each individual service separately. And the essentially Disney or whoever owns this bundle has realized that, you know, it's unlikely that they'll get the same number of consumers to buy each individual one. But if they sell the bundle for a little bit cheaper, they'll get like, well, I'll do that because it's cheaper than buying Disney, Hulu, and even like ESPN and HBO separately. So if they can realize that there's a willingness to pay for different goods, they can just bundle everything together and sell it for a little bit cheaper price. And then that's another example of price. Okay. All right, so that's chapter 10. Okay, so we've gone through the main points, or not main points, but content I wanted to cover for chapters 11, 12, 13, 14. Now, the rest of the class, we have to cover chapter 15, and there's some game theories, some strategic games, and I wanted to review the different types of markets. Why don't we take a quick break now? It's about 9:52. Why don't we just start back at 10, if that works? Let's take a 8-minute break and resume at 10. That should. All right, we'll get started here in a second. Let me just allow them. All right, is everybody back?
Yeah.
Okay, cool.
Yes.
All right, great.
Yes.
Yes, Professor.
All right, let's do it. Okay, so before we jump into game theory, I had posted one more thing under lecture slides, which is this, the 4 market models summary. So I'm just gonna download this. Okay, so what I wanted to just highlight real quickly, because this wasn't done like in the same section of chapters in the textbook, but we've talked about thus far perfect competition, monopoly, and a little bit about the in-between markets, but I just wanted to highlight the difference. So it should be pretty clear at this point what perfect competition is, right? So we know that that is perfectly elastic demand, like the farmers market apples. They're price takers, and the market price is determined by long run equilibrium. We had perfect substitutes, agricultural produce, farmers market items. And we highlighted monopoly, which was demand is much more inelastic. Monopolists can set the price. They're the single seller of a good or service. Big examples were public utilities, electricity, and gas. All right. Now, just to highlight the 2 markets in the middle, which are, in between the 2 extremes of really elastic versus really inelastic. So we call probably the most widely business market monopolistic competition. And in this case, there's substitutes. Demand is relatively elastic, like there's some shopping around. There's some control over price, but essentially the businesses are selling slightly differentiated products, like different types of cereal, different types of Coke, brand versus generic, different types of shoes. There is some advertising in this market. And I think most examples of a business you would think of would go into this market. Again, cereal, shoes, cars, streaming services. There's consumer choice, online shopping. So most things which you buy like in a grocery store or Target or at Amazon, there's quite a number of options. And because of that, we classify this as monopolistic competition. And the big, the one line for that is the consumers are selling slightly differentiated products, right? So there are lots of sellers of cereal, but they're all different types of cereal. There's lots of sellers of shoes, but there's all different types of shoes. The same with cars, right? So this is probably the most widely populated market. Now, the one we're going to spend the most of the time on the rest of the day is called oligopoly. And think of this one as a few large firms. So demand is inelastic, but not as inelastic as monopoly. We're selling differentiated products, but there's some options, just not tons and tons of options. And so think of this market as the big brands, big companies, big tech, big advertising. And some of the main examples are like, and when you look at through all these examples, you'll probably see that there's some options, but not too many. Like smartphones, right? There's maybe 3 to 4 options. Operating systems, there's 2. Game consoles, this is like PlayStation, Xbox, and whatever Nintendo has. And that's really it, right? Rideshare services, there's Uber and Lyft. this actually might move into the other category now, but that's why I had a question mark, is streaming services. We could make the argument that there's, I'm gonna make the argument, this is going into the other category. Because I think we'd agree there's enough options for streaming services. Oops. That is no longer, right, you can shop around. Okay, so I think let's take that out of the purpose of this example. Online shopping auctions. There's eBay and I don't know what else there is. Online book sales, you can still think of Amazon as at least the online. I don't even know if you can buy book sales from other places, but maybe you can. Cable TV, even though this is less common these days, is normally you have a couple options like Cox or what's the Spectrum, the Dodger Lakers service. Home internet, you probably have a few options like Verizon or Cox or whatever it is. And then music streaming services. There's Spotify, there's a few other ones like Apple Music, but the point of all these is most of these things are techie, and most of them there's one or two or less than 10 really big companies or products. And because of that, the competitors in these markets have to be aware of their competition, because what they do is directly correlated with the other companies. So the game theory comes into the most in this market, a little bit in this one, but the most in oligopoly. So I posted this, we went through that pretty quickly, but is it clear on the difference between these types of markets? Oh, take that as a yes. Okay, so take a look at this. And the idea that, oh, I didn't go to the top part, but one way to think of this is like from left to right market power increases. So think of like perfect competition as having the least market power and monopoly having the most. And then, this is like the ranking system. And then control over price also increases from left to right. Perfect competition, like the farmers market, has no control over price, and monopolists have 100% control. And like oligopolies have quite a bit of control, but they still have to worry about their competition. And cereal, shoes, cars, they can set their price, but it's got to be within the realm of what the market says it is. You're not going to sell cereal for $20. You're not going to sell cars for $5. I mean, it's got to be within the market range. And then importantly, demand gets more inelastic from left to right. So flat demand curve, option 2, pretty flat demand curve. It's getting steeper, and the monopoly would be on average the steepest, because your consumers don't have the option to shop around for utilities or gas. They either buy it or they don't. And so these three conditions, as you go from perfect competition to monopoly, should give you a good idea of where these industries sit in terms of comparison to each other. Okay, questions on this before we jump into game theory? The most bullet points for oligopoly, I guess. Okay. So just the only change I made was I took streaming services from oligopoly to option 2, monopolistic, because of all the options, I convinced myself that it should be over here. So the one on the website, just visually think this one goes over here. Right. All right, so okay, chapter 15 is on strategic games or game theory. And so the intro, leading into the chapter from the authors of your textbook, the example is that there used to be a lot of tech, not tech companies, but like electronic companies like Circuit City. What was the
Rise,
prize? Yeah, that was another one.
Radio Shack.
Radio Shack is the one I was trying to think of. Yeah, Radio Shack. So there used to be all these different Best Buy-ish stores before Amazon, and then Amazon kind of took over that market, and a lot of those companies, if not all of them, went out of business except for Best Buy. And the claim is that Best Buy was able to maintain its position as a brick and mortar store because number one, they realized there was still somewhat of a market for that because a lot of those electronic goods, you kind of want to see it. And I think another thing is like what they realize is that a lot of those things are big, like big in size, and having the option to return it is pretty valuable because if you buy like a washer dryer on Amazon, how do you return that? You can't really move it. So I think, and then what they did, the most recognized strategy was they announced that they would match the price of any online competitor. I think they still do this. And so if you go into their store and you show them a price that is lower than theirs, they'll match it. You have to do the research, but they'll match it. And so given that strategy, they've been able to, continue as a pretty big part of the market. I don't know where they are compared to Amazon, but there's a lot of Best Buys. It doesn't seem like they're going anywhere. They're usually pretty busy, and I would say they're usually like, I don't know if anyone's worked at Best Buy, but they're usually like overstaffed, but also difficult to get service for some reason. But other than that, they got a pretty good strategy going on, and they really continue pretty in the TV market, the home stereo market, even appliances, coffee makers. I think they might also be in like the record CD industry still, but and computers, obviously, laptops, desktops, even smartphones, stuff like that. And also like so I don't know what you call the market of like the Ring and the home cameras, but that as well. So by this, pretty ingenious strategy to continue to match the prices of their competitors, including Amazon, they've been able to not have to worry about prices because if someone charges lower price, they'll match it. And Amazon's not going to, they change their prices all the time, so they're probably not going to. I guess there could be like a test strategy of like Amazon or someone else to be like, let's just lower prices for like a week to some ridiculous amount and see what happens to Best Buy, but that hasn't happened yet because then they'd lose revenue. So anyways, that's a good historical example of price competition.
Professor, I think a big part of Best Buy as well as Geek Squad because they help with installations and service.
Yeah, that's a good point. You're right. They have like a service, or even like a subscription. I think my wife and I have it, but I can't remember anymore. But they used to, which they stopped doing because it wasn't cost competitive, was that Geek Squad service. They would offer free installations for any product, and it turns out that that wasn't a cost-effective strategy because people were just getting everything installed. So I think they took that away, but they still have that service, which is, yeah, which consumers, as you pointed out, value. And so that, in addition to this strategy of pricing, it doesn't seem like Best Buy is going to go anywhere. And it really doesn't seem like they have much competition in terms of that type of store. So. Okay, so next we need to define something called a Nash equilibrium, after, you know, the mathematician John Nash. If anyone's seen the movie, A Beautiful Mind with, Russell Crowe, that highlights, his, I think it might have won Best Picture for that performance, or that, acting performance, but it's pretty good. It shows the, schizophrenia nature of that mathematician, what he was able to accomplish, but it also didn't seem like a very good, you know, it seems like a difficult life to be that, have that kind of schizophrenia, but also that genius. But anyways, it's a illustration of that person, John Nash. But what a Nash equilibrium is, in definition, it's a pair of strategies, one for each player or business or whatever, in which each strategy is a best response to the other. So it might not make any sense just looking at the bullet point, but when we look at these games, and if you can determine that both players or firms are choosing their best option, no matter what, then we call that a Nash equilibrium. So the best way to jump into this is to look at an example here from your textbook. So this is a sequential game, it's called, because there's a sequence of moves. And the way to figure these games out or solve them is to go to the end of the game and then go backwards. So essentially, we have an incumbent and we have an entrant. So think of the incumbent as some businesses that has been around for a while. And then the entrant is someone that might come into the industry. So maybe the incumbent is like Uber, and the entrant was Lyft at the time. And you can see the way the game is structured. It's a simplification, but it's valuable to see how you can how the entrant's decision would be affected by the incumbents and vice versa. So the game is such that if like if Lyft enters the industry, the incumbent can either accommodate the entry or fight it, and then or the entrant can just not enter, stay out. So and then they have it such that the payouts are for the entrant blue. Let's say this is Lyft, is the blue one, and then the red one is for the incumbent. So think of it like if Lyft, the entrant, stays out, they get nothing because they didn't enter, and then the incumbent gets 10 million, or let's say that's million. All right, if they choose to enter, the incumbent can choose to either accommodate the entry or fight it, and then these are the payouts. So if Lyft enters and Uber accommodates, they both get 5 million. If Lyft enters and Uber fights, they both lose 5 million. So based on what the incumbent would do in terms of choosing, the entrant can see what they would want to do based on that. So if you go to the last choice possible, which is the incumbent, like Uber, they could either, so if they get the choice, they could either accommodate and get 5 million, or they could fight and lose 5 million. So what's the better option for Uber? Accommodate and get 5 million. So that if this is the way the game was forecasted or set up, Lyft would know that if they enter, Uber's going to accommodate and they would get 5 million. And if they stay out, they get nothing. So knowing that, you know, there is not a good, why would and think of it like fighting is so costly because there's like lawyer fees and all these additional costs. So if Lyft knows that accommodating is the better option for Uber, why would they fight if they're going to lose 5 million doing it? So essentially they've determined that if they stay out, they get nothing. And if they go in, they're likely to get the 5 million. They would go in, and then this 5-5 conclusion where Lyft goes in, Uber accommodates would be the equilibrium. So that's, and then later on we'll see how to set up these little games with just a word problem, but this is the idea is that you want to go to the final decision and go backwards because the first mover can see what the second mover would do. And based on that projection, that will determine if they want to do this or that. Okay. So we'll look at a few more of these, but that's the idea. And these concepts might be a little bit different than what we've done previously. So if you want me to reiterate something or go over it again, I can do that. Next slide. Okay, so this was a sequential move game. And now we're going to look at simultaneous move games in which we have two, well, when we get to it, like two companies or firms. But the best way to look at it to understand this concept is to look at this situation called a prisoner's dilemma. And this will help illustrate the concept. So let me see if I can, this is from the textbook, but it helps to be able to work through it. So I'll make this bigger. I'm using an older template to illustrate this concept. Okay, so no, we don't want to have that yet because we haven't done. So if I can set up this game like the way it's structured in the example here. So we have Frank and Jesse. So I'm gonna put Frank on the top. Okay. And Jesse down here. And you're welcome to, when you do these questions, I'll share this template and you can modify it if you want. It might be easier just to do it on a piece of paper with like graphing paper, but it's up to you how you want to attempt these, but it helps to get it set up and then work through it. So both Frank has two strategies, confess, what it's called, stay mum, but I don't know, I'm just gonna call it don't confess. I'm not British. Don't confess. Okay, and then Jesse can either confess or don't confess. All right, and if both of them confess, they both get 5 years in prison. And so the setup here is like, the example is like two bank robbers get caught and they have an incentive to confess on the other one. But if they don't confess and the other one confesses, then they get more prison, like if you give out the other person. So if they both confess, it's -5, -5. Okay. Oh my God. Well, that didn't work. Maybe I need to put a little. There we go. -5. There we go. Okay, so they both confess, they both get 5 years in prison. If they both don't confess, they both get 2 years in prison. Okay, and then if one confesses and the other doesn't, so what they're trying to like, get out of it is offer the prisoners is if one confesses on the other, then the other one goes to prison and they get to go free. So confess, don't confess is no jail, -0 and -10. Okay, and then the same, I think, was reciprocal here. Comma, -10, -0. Okay. So we've set up the game. So in the way that these are normally structured is that the 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 number on the first number before the comma goes to this competitor, and then the second number goes to the top. So just think of it always as that, like in this situation, like they both get 5 years in prison. In this outcome, if Jesse confesses and Frank doesn't confess, Jesse gets off free and Frank goes to prison for 10 years. And vice versa here, if Jesse doesn't confess and Frank confesses, then Frank gets no prison and Jesse goes to prison for 10 years. So think of it like that, like pay off of this, the left side first, then pay off of the right side second. All right? Yeah. Okay, so the point of this is to illustrate each person's best response based on both options of the other. So first, let's think of it, let's start with Jesse, because we're on the left side. So what you want to do is see, like, if Frank is going to confess, what is Jesse's best option? So we're only looking at this little segment. So assume Frank confesses. Jesse could either confess and go to prison for 5 years, or don't confess and go to prison for 10 years. So based on just Frank possibly confessing, what is Jesse's best option? Confess or don't confess?
That's
Confess, right? Okay. Okay, and then looking at if Frank is going to possibly confess, so if Frank confesses, sorry, if Frank doesn't confess, Jesse can confess and not go to prison, or don't confess and get 2 years in prison. So he would obviously want to confess and not go to prison if Frank doesn't confess. So if Frank doesn't confess, Jesse's best option is also confess. Okay. And then you could probably guess that, like, you could look at the other way, but it's going to be the same. But just for thoroughness, if Jesse were to confess, Frank could either confess and go to prison for 5 years, or don't confess and go to prison for 10 years. So the better option, prison-wise, is only go to prison for 5 years, confess. Okay. And then last scenario is if Jesse were to not confess, Frank's options are confess, go free, or don't confess, go to prison for 2 years. And the best option would be to not go to prison, confess. So what you've seen here in this hypothetical example is that even though, because they're both being interrogated, they haven't had a chance to, talk to each other after getting arrested, the best option, if from a universal standpoint, would be just to go to prison each for 2 years, right? I mean, since that's the only group scenario that would be best. But because they don't want to risk the other person ratting on them and confessing, the best response is always confess, confess. So what we've seen is that this illustrates that without any collusion or agreements, Frank's best option is always confess. Jesse's best option is always confess, and then this would be the Nash equilibrium, where they're both confessing because they don't have, they don't know if the other person's going to confess or not confess. But given that just playing a best response, like it's best to confess, rather than risk, going to prison for 10 years. But, if they knew this was the situation before and they knew they were gonna get arrested, they could probably agree on both those anything. But that's the idea, is that, it illustrates the concept of a best response is not always the best universal concept, but if you or your partner in crime or a business doesn't have knowledge or, communication with others, often what they want to do is just look at what they should do to respond to the other and do that. Or at least that's the option of Nash equilibrium. So working through this example, the best response for both players is confess, and therefore the only situation where they're both choosing their best option is confess. And then this highlighted cell would be the Nash equilibrium. Yeah. Okay. Is that somewhat clear? Or we'll do more examples, but that's the idea, at least to start, is look at what the best response is from one person compared to the other person's options. And then if there's a scenario where they're both choosing the best option no matter what, that's the Nash equilibrium. And then these other situations wouldn't occur, right? Like Jesse would want to don't confess if Frank confesses, but Frank's not going to do that. And then Jesse would want to confess if Frank doesn't confess, but Frank's not going to do that because their best choice is always confess. All right, hopefully that wasn't too confusing, because okay, the good news is we have another example kind of like that, but in this case, so the point is we can apply this concept of Nash equilibrium and the prisoner's dilemma to business scenarios, and we can understand why some of the outcomes occur, even though if they could collude and reach an agreement, which is illegal, they would do that. But why don't we look at this pricing example of Amazon and Best Buy and apply the same logic, and you'll see that just looking at it, if you were both companies, you'd want to pick something, but based on no collusion and your best responses, that's not always the option because of your fear of what your competitor would do to your response. So let's set this one up, just like we did last. Okay, so we've got Amazon on the top, and we've got Best Buy down here. Okay, and the strategies are price high or price low. That's it. Okay, and then price low. Okay. And then the payouts, let's just say these are in millions or something, would be first one goes to Best Buy on the left, and then let's just so Amazon can price high or price low, Best Buy can price high or price low. And the payouts would be if they both price low, Best Buy gets 100 and Amazon gets 160. They both price high, Best Buy gets 300 and Amazon gets 480. And if one price is high and one price is low, in this scenario, if Best Buy price is low and Amazon price is high, then Best Buy gets more of the profit because they're buying the cheaper product. And vice versa here, if Best Buy price is high, this is why they didn't do that with the price match, they would get 0 and Amazon would get 640, okay? So we can work through the same logic and possibly determine a Nash equilibrium with these guys. So let's look at how Best Buy would respond to Amazon. So if Amazon were to price low, Best Buy could price low and get 100, or price high and get 0. It's pretty clear that they would want to price low and get the profit. Okay. Now, if Amazon were to price high, Best Buy could price low and get 400, or price high and get 300. Again, their best option is to price low. Okay. What about Amazon responding to Best Buy? If Best Buy were to price low, Amazon could price low and get 160, or price high and get 100. This is the better option. Okay. If Best Buy were to price high, Amazon could price low and get 640, or price high and get 380. So again, their best option is to price low. So we can get to a scenario where the only choice where both companies are playing their best option is price low. And that would be the Nash equilibrium, because in response to the others, without some agreement or collusion, they don't want to risk pricing high and the other pricing low, right? And you could see, like, if Amazon and Best Buy could, get into a secret room and make an agreement and be like, we're both going to price high, and no one breaks the agreement, this would give them both better revenues of the high price scenario. But because number one, collusion is illegal, and because number two, Best Buy probably doesn't trust Amazon, they're both left with pricing low. And essentially this is what Best Buy has done, is match Amazon's low prices. They get less profit because they're not Amazon, but it has worked. And they're not going to risk trying to overprice Amazon. And they give it to the consumer to do the research and be like, okay, if you show me a lower price. I wonder if anyone's ever tried to bring in a false price, be like, Amazon's selling this TV for $20 or something like that. But I'm sure that Best Buy is able to double check. But so this is the idea of the prisoner's dilemma, but this is how it's applied, and this is a lot of times how you can think of the outcome, in that competitors or substitutes matching their lower prices, because if they didn't, this is the outcome they're facing, right? And without collusion, which they both want, but in most cases is illegal in the US, you have to assume your competitor is going to react to how you react. And so just to be clear, like the little yellow scenario is the Nash equilibrium. Okay. So we'll do more of these, but questions on this concept at this point? I think it's kind of fun, but it might take a bit to wrap your head around what we're trying to solve, but it's a pretty simple but fun way to look at these game scenarios and, you know, make it a good representation of what might be going on, even though it's a little more complicated, but I think there's a lot of value in these scenarios. Good. What's next? Okay, actually, that was my last slide. We do have a pretty game theory-ish homework assignment that we can start on. And work through some of the examples, and then hopefully you all can finish it with the references. But we can move on to in about an hour. All right, should we look at some homework questions?
Yes.
Good. Uh, Homework assignments. Okay, here's the homework assignment that is due next week. So essentially, this assignment is all game theory from chapter 15. All the other stuff that we talked about could be on the final or just for discussion, but this homework assignment is pretty much just game theory. And there's some questions from the back of chapter 15 that I put on there. And then I have a couple questions that I've prepared previously that are pretty good questions, I think, to help learn the concepts. And so we'll, time permitting, we'll go through one of these big examples, and then you can do the other one by, you know, comparing the one we did together. So, let's see how much time. I think we have time to look through the ones in the back of the chapter really quick, and then at least do, I want to make sure we do one of these big examples so you can use it as a reference point to the other. And then that'll help you understand the concepts. So why don't we start with looking at the end of chapter. At the end of chapter 15, let's look at, I put some together because they're grouped. So let's part A will be chapter 5 homework problem, questions 3 to 5, because they're all based on the same concept. So use the following to answer questions 3 to 5. All right. Okay, I can just highlight this one so it's easier. Okay, consider the following information for a simultaneous move game like the ones we just did. 2 discount stores, Megastore and Superstore, are interested in expanding their market share through advertising. The following depicts the profits of both stores with and without advertising. So essentially, the Superstore could advertise or don't advertise, the Megastore could advertise or don't advertise, and the outcomes are here. And you can clearly see that, like, if they both don't advertise, they're saving their advertising budget. But if they both advertise, they're at risk of the other one not advertising. So same situation, but it's a advertising game instead of a pricing game. Okay, so a Nash equilibrium is, if we just run through it here, you can see that if the Megastore would let's start with it. If the Superstore would advertise, the Megastore could advertise and get 95, or don't advertise and get 65. So they would want to advertise, right? And if the superstore were to not advertise, right, the megastore has an opportunity to advertise and get 305, or don't advertise and get 165. So in either scenario, they would advertise, right? So here, advertising 95 is bigger than 65, and here, advertising 305 is bigger than 165. Okay. Now, in response to the superstore responding to the megastore, not sure which ones is a, I guess a megastore is looking at a superstore, given the payouts. So if the megastore were to advertise, the superstore could advertise and get 80, or don't advertise and get 50. So they would advertise. If the megastore were to don't advertise, the superstore could advertise and get 285, or don't advertise and get 115. So we've gone through all the scenarios, and the best response for both the superstore and the megastore to any other option is to advertise, right? So if they're both always going to advertise, then that has to be the natural equilibrium. The natural equilibrium is the megastore to advertise and the superstore to advertise, right? And part 4 and 5 are also follow-ups to this one. So this is the same answer. So when the stores reach the natural equilibrium, their profits will be 95 and 80, right? Yes. Okay, and then 5. If collusion were not illegal, it would be optimal, question mark, for, if there was collusion, is there an option in which both firms could increase their profit? Here, the not advertising one would lose out, and the same here. But if they both could agree to not spend their advertising budgets, then they could save that money and just increase their profits with illegal collusion. So with collusion, if it wasn't illegal, the profit maximizing agreement would be don't advertise, don't advertise. This one. Okay. Yep. Right. Okay, makes sense?
What's, number 4, I don't think it's that. Opportunity.
It's 95 and 80, because they're both advertising, right?
Okay.
Yeah. Okay, so that's questions 3 to 5. That's that one section. What was the other? Okay, multiple choice questions 8 to 9 also go together. Okay, so here we go. We've got another low price, high price scenario. If the game is played only once, then let's see. All right, we're gonna do the thought exercise again. So firm A and B can either charge a high price or a low price. Let's look at their best responses. If firm B charges a low price, then firm A would also charge a low price because they don't want to lose the 10. And then if firm B charges a high price, again, firm A could charge a low price and get 50, or a high price and lose out the 25. So essentially, firm A is always going to respond with low price. And would the firm B also do the same? Let's see. Firm A has a low price. Firm B can price low and get 0, or price high and lose 10, they'd price low. And if firm B charges a high price, firm A charges a high price, firm B could price low and get 50, or price high and get only 25. So again, the best response for both firms is to price low, even though if collusion were allowed, they would both price high, because they don't want to risk being priced higher than the other because they'll lose all the customers. So if the game is played only once, firm A will charge a low price and firm B will charge a low price, right? Okay, 9. Suppose the game is infinitely repeated. What strategies will each firm likely use? Well, if they can both reach an agreement, so what I suppose what they would do, and this, I didn't highlight this portion in your textbook, but if the game is repeated multiple times, what they could do is look at the outcome and choose an option and choose it until the other company doesn't choose it anymore. So maybe they look at this and say like, okay, this is going to go on for years. I'm just going to price high. And if my competitor also prices high, I'll keep doing that. But if they decide to undercut, then they're going to go back to the low price. So if the game is infinitely repeated, what strategies will each firm likely use? So I think this doesn't tell the whole story here, but they would, firm A would charge a high price and firm B would charge a high price, unless the other firm breaks the agreement. So it's essentially, let me write this one out. So this is question 9. And I'm just gonna write out what I just told you. Basically. Okay, so the last part was, suppose the game is infinitely repeated, what strategies will each firm likely use? So we know that the options are charge a high price or a low price. So what we determined is that firm A will charge a high price and firm B will charge a high price. And then both firms will likely keep this strategy unless the other firm breaks the strategy. So essentially both firms will continue to price high, unless the other firm starts pricing low. Okay, in that case, both firms will go back to pricing low. Is how I would summarize the outcome. Now, you could just assume that eventually one's gonna price low and they go back to pricing low. But it depends on how long this game is repeated, and how much, if they wanted to try out both pricing high and see if they keep going with it. For example, like if Amazon were to raise prices and Best Buy were to raise prices to match that, they would probably keep doing that unless Amazon then lowers the price. If Amazon then lowers the price in the future, then Best Buy is going to match that price. So it's a bit of I don't think the answer is just one of these. I think it's some combination of this one and this one. Or I guess they try this until someone does this, and then they go back to this. Okay. All right. Question 10.
Quick question for number 8.
Yep.
What was the answer for number 8?
The answer for number 8 was firm A will charge a low price and firm B will charge a low price. Right? Because if they play it only once, then they don't want to risk the high price, low price scenario. So the answer to A is the Nash equilibrium, which is firm A charges a low price and firm B charges a low price. This one. Okay, multiple choice question number 10. Okay, this one is a bit of so you're a real estate developer owning a piece of land in the Bahamas next to an equally sized piece of land owned by a competitor. Both of you have the choice to build a casino or a hotel, and the payoffs are as such. So the question is, how much is it worth to you to get your casino permit first? So this becomes what if it was a sequential game scenario? And let me see if I can illustrate here. So I'm pretty sure the answer is, I know the answer. Okay. So let's look through this one. And then if we don't agree, I can try to draw it out. But so let's see. Let's just look into first. It's a simultaneous move game. So let's look at. Wait a minute. Oh, that's good. I was like, why is my competitor? So this is us, and this is your competitor. Okay. So let's look at what we would do compared to our competitor. So if our competitor builds a casino, we can do a casino and get 3 million, or a hotel and get 5. We do the hotel. If the competitor builds a hotel, we would build a casino, right? So in this case, there is no Nash equilibrium because, and then go back to what the other person would do in response to us. So if we do casino, they would do hotel. If we do hotel, they would do casino, right? So initially, there isn't a situation where there would be a Nash equilibrium. Now, the question is, how much is it worth to you to get your casino building permit first? So if we start with building casino, right, then they're going to respond by doing hotel, right? And we'll get this. So if we get to go first, the question is, if we get to build our casino first, which is more valuable, we start with this and this is out. So then, they're gonna choose either 3 or 5, and they would choose this. So otherwise, I guess. Well, I guess if we both get the casino at the same time, it's 3 million. And if we get it first, it's 20 million. So I suppose it's 17 million to get the permit first. Trying to think if that's. Compared to them getting the. Yeah, I, I thought this one was more of, you draw a sequential game, but because there was no initial equilibrium, I think the answer has to be 17 because originally there was no national equilibrium, right? So if we basically, like, if one did casino, we did hotel, or if they did hotel, we did casino. So we don't know what's going to be chosen. Now, if we get our casino permit first, we're going to do that. We're going to get the 20 million, and they're going to get the 5. So I think it has to be worth this difference than this, which is 17, because either, or wait a minute. No, I've changed my mind. So it's okay. So if they get the casino permit first, right, then we would respond with hotel, right? If we get the casino permit first, then they would respond with hotel. So now what's the game? So either we get, either they go first, they do casino, we do hotel, or we go first, they do hotel, and we get the 20. So the difference is the 5 versus the 20. So 15 million, right? Yeah, okay, that's the answer. So I had to think of that for a second. But the question is, there's no Nash equilibrium because the other person would do the opposite of the other. And now it's a question of, like, who, if someone gets the casino first, what's it worth? So if our competitor gets the casino permit first, they're doing casino and we're doing hotel. So it's this. So we get 5 million. Now, if we get a casino permit first, we do casino, they do hotel, we get 20 million. So the difference, or the value of the permit getting it first, is going from 5 to 20, which is 15 million. Yeah. You agree?
It's still, kind of an abstract concept for me at this point.
Okay. All right, well, I'll take the answer is 15 million that we looked at. Okay. Last one from the textbook is 15 for salary negotiation. Okay. All right, so the figure at the bottom of the page represents the potential outcomes of your first salary negotiation after graduation. This one here. Question? Okay. Assuming that this is a sequential move game with the employer moving first, indicate the most likely outcome. Okay, and then, well, let's do that one first. So here we go. If the employer goes first, we can choose low salary and high salary, all right? Now, you can see that the employer would figure out that if we get to one of these options, we know what we're gonna choose. So if we get this low salary offer, employee gets 75 for accepting or 0 for not accepting. Okay. So if we get the low salary offer, we can either accept and get 75 or not accepting at 0. Okay. Or if we get the high salary offer, we can either accept and get 100. Why they employee? This is flip-flopped. Okay, so low salary offer, we walk and get 0, or we accept and get 75. High salary offer, we walk and get 0, or accept and get 100. Now, okay, the point of it is, either way, we either accept it and get the salary, or we don't accept it and get 0. So the employer knows that whichever offer we get, assuming there's not other offers, it's going to be accepted. So the employer's best solution is to offer the low salary offer, because in that case, the employer would get 100 and we get 75, versus the high salary offer where we get 100 and they get 75. The point is, the most likely outcome is the employer would know that the employee is always going to accept, and they're going to choose the offer which gives them the higher outcome, which is the low salary offer, where the employee accepts and gets 75 and the employer gets 100, versus the high salary where the employer would only get 75. Okay, so the most likely outcome is employer offers low salary, employee accepts. And does the ability to move first give the employer an advantage? Yes, it does, because they know that any offer is going to be accepted, and they have the advantage, right? So if they know, like, the end of the game, they're going to accept the offer of the employee, then they have the advantage of going first and knowing what the employee would do. Okay. And then as the employee, is there anything you could do to realize a higher payoff? I don't know if this is like a supplemental question, but I guess there's like salary negotiations or whatnot, but I don't think that's part of this game tree. So I think the full answer to this one is the most likely outcome is employee offers low salary, employee accepts it. The ability to move first does give the employer an advantage, yes. If so, how? Because they can determine what the employer would do, and based on knowing what the employer would do, they can make the offer that maximizes their outcome. And as the employee, us, is there anything you could do to realize a higher payout? I suppose there's, salary negotiations or something like that. Okay. Questions on that one? All right. So we did, I think, all these questions for part one. All right, so we should be good on those. Now there's two more big questions. Let's, if we have time, we'll do one of them together. And then you can do the other one to finish your homework. So these are both multi-part game theory questions I've set up or I've written from before that I think tie into this chapter. There's one section that we have to introduce uncertainty, but it won't be too difficult. And other than that, it's either a one-time game or you have to develop a game tree and determine what the outcome would be. Okay. All right. Everybody good? We ready for one more big question? Yeah. All right. I'm gonna go back to my. This, okay. Okay, the question is, game theory A. So suppose Toyota and Hyundai play the following simultaneous move game. Toyota has two pricing options for its 2020 Prius. Similarly, Hyundai has two pricing options for its 2020 Ioniq. Both Toyota and Hyundai can either price their new hybrid vehicles at 20,000 or at 25,000. If both price at 20,000, each earns profits of 3 million. If both price at 25,000, each earns profits of 4 million. If one prices at 20,000 and one prices at 25,000, then the company that undercuts gets the profit. The company that prices at 20,000 earns 5 million, and the company that prices at 25,000 only gets 1 million. So first part is let's put Toyota on the left side of the payoff matrix or the chart thing. With Toyota's profits listed first and Hyundai's profits listed second. And part A is if they play the game only once, draw the payoff matrix and define the Nash equilibrium. So this is similar to the like 2 or 3 we've already done. The only thing you have to do is set up the game beforehand. So let me use this example again, or this template. Okay, let's put Toyota on the left side. Okay, so the options are they can either price at 20,000 or price at 25,000. Okay, there's one option, and the other option is price at 25,000. Okay, Toyota can either price 20,000 or Toyota can price at 25,000. Okay, and if both price at 20,000, they both get 3 million. Okay. If both price at 25,000, they both earn 4 million. Okay, and then if one prices at 20,000 and the other prices 25,000, the company that prices at 20,000 gets 5, and the other earns 1. Okay. So here is the scenario. All right, so we see how to set up the game. You put the options for each company, and then the payouts. Now, if they play the game only once, what are they going to choose? So we probably see this coming, but if Hyundai prices at 20,000, Toyota could price at 20 and get 3. Wait a minute, did I flip flop these? Oops, yeah, sorry, this is wrong. This should be 1 and 5. Okay, yeah. So if they both price at 20,000, they both get 3. They both price at 25, they get 4, and then if the other one underprices the other, the underprice gets the 5 and the overprice gets the 1. Okay. All right, so if Hyundai prices at 20, Toyota could price at 20 and get 3, or 25 and get 1. So they would want to do the 3. Okay. If Hyundai prices at 25, Toyota could price at 20 and get 5, or 25 and get 4. They'd again want to do the 20,000 price low. And then vice versa for Hyundai. If Toyota prices at 20, Hyundai could price at 25 and get 1, or 20 and get 3. They would do that. Okay. If Toyota prices at 25, Hyundai could price at 20 and get 5, or 25 and get 4. This would be the better option. Okay, so again, you can see that without any collusion and playing only once, the best response for both players, both companies, is to price at 20,000, and then this would be the Nash equilibrium, where both price at 20,000, both earn 3 million, right? Right. So we drew the payoff matrix. We define the Nash, which is the yellow cell that down there. Right? The Nash is they both price at 20,000, and they both get 3 million. Okay. This part here is a little bit of a additional concept, but it's important to tie in the repeated game part.
So there was like a 3 and 3, but the bottom line was like a 4 and 4. Do we still like choose like 3 and 3?
Yeah, so if they play the game only once, they do 3 and 3.
Oh yeah.
Yeah. Yeah. Okay. Now part B is the play the game repeatedly with an uncertain final period. So now assume Toyota and Hyundai play the game repeatedly, and there's an uncertain final period. So in other words, they're gonna play it, the game's gonna end at some point, and all they could do is put a probability on when the game will end. So specifically, there's a 25% chance that Trump will ban hybrid vehicles in any given period. So there's 25% chance. Both agreed to price their new hybrid vehicles at 25,000, right? Because that outcome would give them higher collective profits if neither one breaks the agreement, provided neither company cheats on the agreement. So this is a collusion example, or like a handshake agreement that both companies could do, assuming that the other company doesn't break the agreement. So if they keep the agreement, they get a certain amount. And if they break the agreement, the other company would also break the agreement and they would get a certain amount. So first, what is Toyota's profit if it cheats on the agreement? So the first thing we need to do is determine the likely number of times that this game would be played. So you could just think through it with the probability, but a rule, or just the way to determine based on the probability, in this case, it's like a little theta thing from a different textbook. But if you go here and delete this thing. Okay, so this was part A. Call this part B. Okay, so a simple way, what you need to do is determine what is the expected number of times this game will be played. Okay, and that's a question. So okay, and the way you want to do that is they give you a probability. So if you just divide that by 1, so 1 divided by the probability the game okay. So simple way to determine the expected number of times the game will be played is divide 1 by the probability the game will end. So we know that 1 divided by, there was a 25% chance, right? So 0.25. Okay, so what's 1 divided by 0.25 is equal to 4. All right, so now we've determined that with the 25% chance of ending, that it's likely, like, you know, if you add 0.25 4 times, that would give you the 100%. So just for this example, whatever the probability of the game will end, put that in decimal terms, and 1 divided by that would give you the expected number of times. Now you can see that, like, if the probability goes up of the game ending, then you'd probably play the game less, or if the probability is lower, you expect to play the game longer. But in this case, we expect to have 4 rounds because 25% chance would give us a pretty good expectation of 4 times. So we expect to play the game 4 times. Okay, so given that, we know that this outcome, 4 and 4, we'll highlight a different color, is the agreement, right? So this is the potential agreement between the two companies, the two firms, rather. Okay. So if we want to calculate Toyota's profit if it cheats, Okay. What we would do is add up the projected payout. So the projected equals. So if we play if we play the game 4 times, and if Toyota cheats, then let me rephrase this. So think of it this way: like this is the agreement as long as they continue to play it. If one of them breaks the agreement, then this is the short-term cheating, and then they go back to the original without the collaboration. So the projected payout would be Toyota cheating and pricing at 20,000, which would give them the 5 million. And then if they break the agreement ends and they go back to pricing at 20,000. So essentially, the projected payout would be Toyota cheats, they get 5 and then 3 more threes. Okay, and that's because we're going to play the game 4 times, expected. And so if they play it 4 times and don't cheat, then they both get, 4 plus 4 plus 4 plus 4. If Toyota cheats, that means cheating is doing, this is the agreement. They break the agreement and do 20,000. They get the 5 million. The agreement's off, and then the third, fourth, and fifth, the second, third, and fourth time, the agreement's off, and they both go back to the match. So it's a bit of a concept to figure out, but you'll get the hang of it. And like essentially, they would get the 5 million from cheating. Then they play the game 3 more times, right? Total of 4 of the Nash equilibrium. So it's 5 plus 3 plus 3 plus 3. Okay, and the projected payout from cheating would be 9 plus 5 is 14, right? Okay, now what is Toyota's profit if it cooperates? Okay, now cooperating means to keep the agreement for the entire period and no one cheats. So what is Toyota's profit if it cooperates? So the projected payout is not that, but autofill. So essentially, if Toyota does not cheat, right, they would get, if they play the full game 4 times, it's 4 plus 4 plus 4 plus 4. Or 4 times 4. Okay, and that is equal to 16. Okay, so if you can see the scenario here, we're looking at, if there's no agreement, it's this. This is the agreement, but if someone breaks the agreement and breaking the agreement is not pricing it high, instead pricing low, then that happens once, and then the game goes back to the Nash. So here's cheating, pricing high once, getting the profits, but then they go back to both pricing low, and it's 5 plus 3 plus 3 plus 3, which is 14. If they both keep the agreement and no one breaks it, they can get the 4 million for the expected 4 times, and that's a 16 million. So based on the way we did the analysis, would Toyota prefer, or would Toyota likely keep the agreement or break the agreement? Keep it, right? Because they'd get an extra 2 million from keeping the agreement, and even though they got the 5 million the one time, it's not worth it to go back to the 20,000. So this is probably a hypothetical example, but you can see that this is what the two or some companies might get into is like, well, prices have gone up. We're both gonna price in this higher scenario, but if it if something goes wrong or like the other company changes their strategy and starts to price low again, then you got to price low again or you're losing too many competitors. So a bit of a thought exercise, but I think it illustrates this type of scenario pretty well, especially when you take in playing it multiple times, because uh, if you can agree upon this better outcome, it has to do with number one, how many times you think how long that's going to persist, and number two, what your competitor might do in response. Okay. Okay, we have one more part. Everyone, this is probably a bit, it'll take some getting used to, but questions on part A or B so far? Okay, and then finally, there's a multi-stage scenario, which I wrote out here. So finally, assume Tesla and Toyota face a multi-stage game where Tesla is the leader and Toyota is the follower. So that means that Tesla is going to go first and has to decide whether or not to introduce the Model 8, which I made up as a low budget all electric vehicle starting at 20,000. And so if Tesla has one decision, right? Tesla is either going to introduce the Model 8 or don't introduce the Model 8, right? And if this is like a cost comparable car to the Prius, right? So if Tesla doesn't introduce the Model 8, the game ends immediately, and Tesla earns 2 million and Toyota earns 8 million. If Tesla introduces the Model 8, Toyota has three choices. Okay. As the second mover, the options are do nothing. Tesla gets 6 million and Toyota gets 4 million. Sue Tesla, where Tesla earns 3 million and Toyota earns 3 million, or they could introduce the Prius squared, a low budget all electric Prius starting at 20,000. The result being that Tesla gets 5 million and Toyota gets 5 million. Okay, so the point of this hypothetical example is if Tesla is going to introduce a new product, like a low budget electric vehicle, should Toyota respond by doing nothing, fighting, or just doing the same thing that they did? Okay, so let's draw the game tree first. For this, I have a template in Excel. You're also welcome to write this on just a piece of paper if it's easier. I want to, give me 1 second. I'm just stop sharing because I think I have the answer on this template. Stop sharing. There Okay, 1 second. You can see the answer, but okay, okay. There. Okay, so here we go. I had this prepared ahead of time, so it wouldn't take as long, but you can use this template or modify it as such to answer other questions. But essentially, let me illustrate why this is the game tree. So Okay, here we go. There we go. I think we can see everything. So here's the question again. So Tesla goes first and decides whether or not to introduce the Model 8 or not. So they can introduce the Model 8 or don't introduce the Model 8. So that's represented here. Tesla goes first, they either introduce it or they don't introduce it. If they don't introduce it, the game ends immediately and Tesla earns 2 million and Toyota gets 8. So you can see here that Tesla, the first mover, gets the 2 and Toyota, the second mover, gets the 8. If Tesla introduces the Model 8, Toyota has 3 choices. So first is do nothing, where Tesla gets 6 and Toyota gets 4. So that's represented here. The second option is to sue Tesla, where Tesla gets 3 and Toyota gets 3. That's represented here. And third option is for Toyota to introduce this Prius squared, a low budget comparable to the Model 8. And in that case, Tesla gets 5 and Toyota gets 5. So that's here. Okay, so first thing you'll have to do is, for this kind of example, is draw the game tree like this, or whatever represents the question. Again, it might be easier just to do this on a piece of paper or graphing paper by hand. Up to you if you want to use my template, but it's kind of up to you, but this is the scenario. So here's the game tree. So Tesla can do this or this. Here's the payout if they don't. If they introduce the Model 8, here's what Toyota's choices, the 3. And then here are the payouts with Tesla's getting paid first and Toyota's second. Okay, now next question is define the Nash equilibrium. Last question. Okay. So what do we do? How do we solve this scenario? Okay. So what we're gonna do is go to the end first and then go backwards. So why don't we go to the second mover, which is Toyota, and determine what they would do based on the situation they're in. So if Toyota gets to choose, they can do nothing and get 4 million. They can sue Tesla and get 3 million, or they can introduce the Prius squared and get 5 million. So if Toyota gets the choice, what's their best option? Of these 3. So again, they could do nothing and get 4. They can sue and get 3, or they can introduce the Prius and get 5. So of the 3 scenarios, introducing the Prius would be their best option, right? So they would choose this if given the choice, and they would get this yeah. Okay, now Tesla can do the same analysis and figure out what they would get if they introduce and Toyota does this. So Tesla knows that if they don't introduce the Model 8, they get 2 million, right? If they introduce the Model 8, they can see that Toyota is going to introduce the Prius squared, and then we get 5 million. So would Tesla want to not introduce and get 2, or introduce and get 5? They want to introduce, right? Okay, so the way to look at these games is first set it up properly, and then go to the end of the game or the second mover and determine what their choice would be if given the choice. And then knowing what their choice would be, Tesla could go back and be like, okay, if I introduce, I know that Toyota is going to introduce and I get 5. If I don't introduce, I only get 2. So obviously this would be the better outcome, in which they introduce and they get the 5 compared to the 2, because Toyota wouldn't do this or this because they're losing the extra 2 or 3 million. Or 1 or 2 million, sorry. So this scenario, the yellow one, is the Nash equilibrium.
So Tesla introduces the Model A, Toyota introduces Prius.
Correct. Right. Tesla introduces the Model 8, Toyota introduces the Prius. And they both get 5 million. And in that case, they're both choosing their best option. So the best option is for Toyota to introduce the Prius and for Tesla to introduce the Model 8. Okay, and that's it for this type of question. So 3 different types of games in one. You get a pricing game where they just play it once. You get a game where it goes on multiple times, but it's going to end at some point. And you want to see if they're going to make an agreement and stick to it. And then it's good to look at a sequential move game where there's a first mover advantage. And in that case, you go to the end and deduce backwards. Okay. So or I guess first, any questions on this whole problem that we spent the last half an hour doing? Maybe it'll take a little more working with, but okay. Okay, all right, so, well, for next week's homework, if you stayed on this long, you have number 1 done with the homework questions from chapter 15. You have number 2 done, and which you can use as a reference for number 3. So the only question you have to do for the rest of the homework is another one just like the one we did. It's similar but different. There's Nintendo Atari situation. They're deciding on different prices, and based on their pricing, they get different profits. So you're going to have to draw the payoff matrix, play the game once, and define the equilibrium. There's a situation where they play it multiple times, and there's a 5% chance of the game ending. And then based on that, you have to determine if they would keep the agreement or not. And then there's a multi-stage game, which you have to draw the decision tree and work backwards from the second mover, in this case Luigi, and to the first mover, in this case Mario. So it should be very similar to what we just did, but just apply these scenarios and numbers and logic to what's happening here. And the game tree might not be exactly like the one, like here we have Mario goes first, Luigi has 2 choices, and then Luigi could have 2 choices and 2 choices. So as opposed to this one, in the one you're going to do, there's a first mover who has a choice, and then Luigi has 2 choices, and then Luigi has 2 choices based on the other one as well. So it won't be just like this, but pretty similar. I think you can deduce the logic. All right, so everyone feel good about doing the last one at home?
Yeah.
Okay. All right. So this homework assignment, which again is about, you've already done 13 of the 20 points if you participated, so you got a good start. But that's due next week 7, or second to last. All right. Well, we covered quite a bit today, I think, from bubbles and exchange rates to more game theory. and some pricing strategies in between. I think we're almost at time. In fact, I think I might have gone over a minute or two, but had to get through this example. So any final questions or thoughts before we wrap this one up?
Can you share some I don't know, links or books about game theory that you'd recommend maybe in our online class?
Yeah, I can do that. I can do that. So I'd start with reading. Oh, start with chapter. I know you need more context than chapter 15, but chapter 15 in the textbook has some of that. But yeah, I'm sure I can share some additional supplementary reading if that would help.
Thank you.
You're welcome. Okay, well, let me share. Okay, well, that's probably enough for today, so I'll go ahead and end our session, but I'll let me know if you have any questions on the homework or the content, and I'll see you all in a week.
Thank you.
Thank you.
Thank you, Professor.
Thank you. Have a good one.
Too, thanks.
Well, thank you, Professor. Enjoy your weekend.
I will, thank you. And this recording. On one.